Updates on Artemis I, predicting an asteroid strike with stunning accuracy, Webb's view of Titan, and a new adaptive optics system for the Very Large Telescope. All this and more in this week's episode of Space Bites. So last week, we had the historic launch of the Space Launch System carrying the Orion capsule, the Artemis I mission to the moon. And this mission is going to be taking a while. It's going to be ongoing, so we'll be able to give you updates all the way through till December 11th, and I guess beyond. Now, the first biggest thing to really go into is, like, last week, I kind of complained about the quality of the launch footage for the Space Launch System. Where was all the live shots that we've become so accustomed with SpaceX? Well, we got some really amazing video footage of the launch from the perspective of the rocket. So the one that's just incredible is looking down the rocket and seeing the launch and seeing the exhaust plume and then the rocket lifting off and getting farther and farther away from the launch complex. Just a really stunning piece of video. I wish we'd had that live, but it's okay. And then we also got a really cool footage of one of the solid rocket boosters detaching from the core stage as it had gotten farther up. So how's the mission doing? Well, so far it has gone surprisingly well. There's been no major problems with the Orion capsule so far. There was one minor issue, a problem with communications, but that was resolved fairly quickly. The problems have come not with the Orion, but actually with the CubeSat payloads that were carried along with the spacecraft. Several of them have failed. They haven't been able to maintain contact with them. And we don't really know why this was, but definitely the long amount of time that they spent out at the pad going back and forth, having to be recharged, like they weren't meant to spend this much time away from their cozy research homes. And they were built by different groups. In some cases, it was universities. In some cases, it was industry. In some cases, it was NASA. A few that I'm really sad about. There was a Japanese lunar lander on board. There was, of course, the NEA Scout. This was a solar sail going to an asteroid. Both of these we haven't heard from. So that sucks. The other downside was the damage to the pad after the spacecraft lifted off. We saw some photos of the elevator doors that will carry the astronauts up to the rocket in future missions, and they were blown out by the power of the rocket. So those will have to be redesigned. Orion has done a series of maneuvers. It came within 130 kilometers of the moon and then did a series of burns to put it into a retrograde lunar orbit. It's going to do this really interesting trajectory that takes it really far away from the moon, and then it's going to come back to the moon and then drop back down to the Earth and re-enter the Earth's atmosphere, as I said, on December 11th. So I will keep you posted. Next week, I'm sure there'll be more things to talk about. NASA predicted the exact impact of a small asteroid. Me and my companions in the media have gotten most of you sufficiently nervous and worried, existentially dreading the possibility that an asteroid is going to strike the Earth. It's not a question of if, it's a matter of when. But now I think things are looking up. Things are looking better. We've had, of course, the DART impact that showed that we're not afraid of an asteroid. We can reach out and smash it and change its trajectory. And in theory, if there's a bigger asteroid, you just send a bigger impactor. But we got a really cool test of an asteroid early warning system. So on November 18th, astronomers detected an asteroid on collision course with the Earth, and the detection was made with the Catalina Sky Survey. And the asteroid is called 2022 WJ1. The Catalina Sky Survey estimated that there was a pretty high chance that it was going to hit the Earth in about 3.5 hours. Other astronomers were alerted. They were able to make more observations of the trajectory of the asteroid, and they predicted that it would strike the Earth at 3:27 a.m. on November 19th, hitting southern Ontario. Now, this all sounds really scary, but when you learn that the asteroid was 1 meter across, completely harmless, totally burned up in the atmosphere, maybe some pieces rain down and hopefully people can find some of the debris, but it was harmless. But this was an amazing test, right? You had this robot scanning the sky, detecting this asteroid, alerting all of the other people involved. They did follow-on observations, confirmed that this thing was on collision course. And when you think back to some of the more dangerous asteroid impacts that we've had in the past, Chelyabinsk hitting Russia a couple of years ago was sort of one of the biggest examples. If people had more warning that there was going to be this asteroid explosion in the atmosphere, and in this case, Chelyabinsk was a house-sized asteroid, they would have known to stay away from glass windows, to not stare out as they saw the flash in the sky. And thousands of people were injured with that last asteroid strike. So the good news, it just shows that we've got this early warning automated system that's getting better and better. And when you match that together with the prospects of DART and then a lot of other really interesting research that's coming together to show how you can even protect against asteroids which are going to be striking the Earth within a couple of weeks, maybe even days, it's starting to feel a lot less risky. I think we can lower asteroid doom on our list of things that are going to keep us up at night. Yeah. Well, I mean, you've got climate change, you've got the robot apocalypse, you've got a human-made pathogen, you've got nuclear war, you've got overpopulation, you've got like some kind of crazy science experiment that turns the universe into Ice 9. So you got alien invasion. Like, there's all kinds of things to continue being worried about. So if you do need something, you've got choices, but less so on the asteroid front. James Webb sees Titan. So a few weeks ago, we talked about how one of JWST's instruments, the mid-infrared instrument MIRI, had a problem with one of its modes, and it was experiencing excess friction during its filter wheel as it was turning, and so operators decided to take that mode offline. Well, they got it back working, and just in time, because we want to see some observations of Saturn before it is no longer possible to see the northern pole of Saturn, and we have to wait like more than 20 years. But we got this really cool image of Titan, which is of course Saturn's largest moon. And this of course is going to be the destination for the upcoming Titan Dragonfly mission that NASA is sending, a nuclear powered helicopter to Titan that'll be arriving in 2034. But the point is that we thought we weren't going to see Titan. Cassini has died. Nothing until the Titan Dragonfly mission shows up, but no, we got this really cool picture of Titan from Webb. Now the colors are kind of wonky, and what's going on here is that a researcher, Michael Radke, he's a PhD student at Johns Hopkins University. He pulled down the raw data from the Webb observations of Titan. He then mapped out 3 different wavelengths of infrared to red, blue, and green. And so it's not like these are features on the surface of Titan necessarily. These could be concentrations of different gases in the atmosphere of Titan. We're not entirely sure what it is that we're looking at yet. And in fact, Judy Schmidt posted on the story when I posted it onto Mastodon. She was like, I'm not even sure what we're looking at here. So I've encouraged Judy to go back and take a crack and see if she can clean up this image. I also got a hint from the researcher that actually is making the Saturn observations that they'll be sharing those shortly. So maybe, hopefully, next week we'll be able to actually take a look at Webb's view of Saturn. But stay tuned for that. Europe's rover will fly with NASA. So one of the many consequences of Russia's invasion of Ukraine is space exploration. And we saw this with the European Space Agency's Rosalind Franklin rover, which was part of the ExoMars mission. So it was originally a collaboration between NASA and ESA, but then NASA pulled out because of cost overruns with JWST. So like, we're all excited about JWST, but we see some of the downsides of it for sure. Casts a long shadow over space exploration for the last couple of decades. So then the Russians stepped in and they offered to launch the mission on a Proton rocket, which was great. But then with Russia's invasion of Ukraine, that's off the table. There's going to be no more collaborations between Europe and Russia. And so based on this, we've got a problem, no way to launch this mission. And Russia was planning to develop the landing system. When you think about the landing system for Curiosity, you got the Sky Crane, there was going to be a version of that developed by Roscosmos. And so now with Russia out of the picture, ESA is going to have to take on those tasks on their own and design something. So NASA has come back to the negotiating table with ESA, and they've agreed to launch the ExoMars mission with Rosalind Franklin on an upcoming NASA rocket. And we're not really sure what that rocket is going to be. I mean, there's a lot of options. It's probably going to need something fairly heavy to go all the way to Mars. So Starship, a New Glenn, a Falcon Heavy. So we're not entirely sure about the details yet, but NASA has agreed to handle the launch services for this mission, which is great. And it's interesting when you think about it, right? That Europe handled the launch of JWST, and now NASA is going to handle the launch of the ExoMars mission. So it's sort of a nice swap and exchange of these services. Even more atmospheric study on WASP-39b. So one of the first data releases that we got from JWST was the study of the exoplanet atmosphere for WASP-39b. We got this really cool spectra of the carbon dioxide concentrations in the atmosphere of the planet. And it's like this really clear signal that there's absolutely these chemicals in the atmosphere of WASP-39b. This week we got a deluge of journals as well as press releases revealing the full picture of what astronomers understand about the atmosphere at WASP-39b. Not only did they detect that carbon dioxide, they detected carbon monoxide, water vapor, potassium, sodium, and one of the most interesting ones is sulfur dioxide. And this is chemical that is created in the atmosphere of a planet through a chemical process, through sunlight, very intense sunlight hitting the atmosphere, breaking up various atoms, creating sulfur dioxide. It causes acid rain here on Earth. It's of course present in the atmosphere of Venus, and this is the first time it's ever been detected in the atmosphere of another exoplanet. And so you've got this level of analysis of the atmosphere of another planet to the point that you're seeing all of these different chemicals in the atmosphere. You're also seeing the various chemical processes that lead from one type of chemical to a different type of chemical. The data also show cloud levels in the atmosphere of WASP-39b. And I think this deluge of papers is the outcome that you were all hoping for when JWST first launched. I know sort of the common sense has been this telescope is great and all, but I'm a little unimpressed so far with what I've seen. And that's because you haven't seen much. All of the data that's been gathered by JWST so far has been handed over to the researchers. They've been working on it, studying it, performing their analysis, and writing their papers, taking the time to make sure that everything they think they're seeing, they're actually seeing, getting their peers to double check their work and make sure that they're not making any mistakes. And then finally, after many months, they're able to publicly release the results. And what do we get? We get the most exquisite observations of an exoplanet's atmosphere that humanity has ever seen. And this is from one observation with JWST, and it's making dozens every week. And they're all in this pipeline of image analysis and data analysis and peer review and writing the paper and getting them published. And there's this lag. And now we're starting to come out the other side of this lag. And so you haven't seen anything yet. We're just going to see week after week, more and more papers, more and more really interesting data and analysis coming out from JWST. And even like the most skeptical and curmudgeon-y of you all are going to get as excited about this telescope as I am. If you're enjoying watching this video, just remember that the work we do here is just one part of all of the space and astronomy journalism that we do at Universe Today. I've been doing this job for almost 25 years now. We've got an amazing team of writers with incredible background and research, many with PhDs. We have all of the content on Universe Today. We have a weekly newsletter that goes out. We have videos, podcasts, and other media. So if you want to support the work that we do at Universe Today, go to patreon.com/Universe Today. I'll give you no ads on the website for life. You get access to all of our videos with no ads and advance access to other videos. You get to see behind the scenes and other exclusive content with Universe Today. So join our community at patreon.com/Universe Today. The Very Large Telescope got even better. One of the most powerful telescopes on Earth is the Very Large Telescope. I know you love the name. Now it's actually 4 separate 8.2 meter telescopes in Chile, and they're an interferometer. So the 4 of them can work together like one single telescope. But the downside is that they're still trapped under the Earth's atmosphere. And so we've got the distortion of the atmosphere obscuring the images. But the Very Large Telescope is equipped with an adaptive optics system. This is an artificial star that the telescope creates in the sky and then adapts in real time the optics on the telescope to adapt for the disturbances in the atmosphere. And now the Very Large Telescope got an upgrade on its adaptive optics system. They've added a new instrument called the Enhanced Resolution Imager and Spectrograph. And I can say a lot of words about this, but let's just compare the images. So let's look at the before and let's look at the after images of galaxy NGC 1097, which is 45 million light years away. It's so cool. It reminds me of like some of those before and after images of the Hubble Space Telescope before and after they got the problem with the optics fixed. It's amazing. And you know, this work with the Very Large Telescope, testing out new methods of adaptive optics are very important because there is the next generation telescope coming, the extremely large telescope. And it is also going to have an adaptive optics system with many lasers. And it's going to be able to, in theory, be able to image Earth-sized worlds orbiting sun-like stars. And so this process of developing new, more powerful systems allowing Earth-based telescopes to do as good of work as space-based telescopes continues. So enjoy these new images coming from the Very Large Telescope. Explore a cool map of the universe. I get 2 really common questions on my channel. One is there some place that I can see a map of the universe, like the actual universe, so I can wrap my head around it? And the other one is like a series of questions about if people are trying to understand how the farther things are away, the more they're backwards, we're seeing them backwards in time, and how confusing and complex that is. So there is an amazing new website that just came from Johns Hopkins University. It's a map of actual galaxies. So all of the dots in this picture are real galaxies at their real distances. And you can scroll through this as like a timeline into the universe. So at the closest point, you're seeing spiral galaxies, which is sort of how they would look today. And this region extends out to about 2 billion years ago. In other words, the light has been traveling to us for about 2 billion years. But then those spiral galaxies fade away because they're just not bright enough. And so all we can see are the larger elliptical galaxies. And these are the result of spiral galaxies crashing into each other and becoming these big blobs. And they're much brighter, but they're also a lot redder because they don't have the same level of active star formation. And they're able to see these to about 4 billion years ago. And then we see elliptical galaxies, but now the expansion of the universe is starting to shift the wavelengths of the light, so they look even redder. And this goes out to about 8 billion years ago. And then those galaxies fade away. And then all we can see are the quasars, which are, of course, the actively feeding centers of galaxies that contain supermassive black holes. And these are bright and blue. In many cases, they're putting out as much light as the rest of the galaxy combined. And these we can see out to about 12 billion years ago. And then those quasars shift into the red end of the spectrum beyond 12 billion years, and then they even disappear before we get to the very edge of the observable universe at 13.8 billion years ago. It's a fantastic way to understand the universe, and these are real galaxies. Each one of these dots is a real galaxy that was seen in an image seen by a telescope. So hopefully this will help you wrap your mind around this concept and better appreciate when you look at new pictures coming from JWST and other telescopes. All right, those were all the stories that we had today. So if you want to dive deeper into any of them, I will have links in the show notes down below. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 55,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Josh Schultz and Andrew M. Gross who support us at the Master of the Universe level. All your support means the universe to us. All right, that was all the news for today. A lot of news. We'll see you next week.